Hello, everybody. So we finished off the last lecture talking about meiosis, how that differs from mitosis, the products of meiosis, and the advantages and disadvantages of sexual reproduction. So now we are going to talk about how sex is determined, and it's different in different animals. It's not always the way it is in mammals with an X and a Y chromosome. So we're going to talk about that. And then we're going to talk about kind of what happens when meiosis doesn't work perfectly, which it doesn't every time, and some of the impacts of that. So get your notebooks and pens ready, and here we go. So let's get to where we were. Okay, so here is where we are. We talked about types of cell division, mitosis, meiosis, and we are ready to talk about sex determination now. So in mammals, there are X and Y chromosomes, which determine sex, right? So the X is this big guy here, and this itty bitty little one is the Y. So in humans, we have 2 copies of every chromosome, 1 through 22, right? We have 23 chromosomes, 2 of each. So we have 2 copies of number 1, 2 copies of number 2, 2 copies of number 3. Females have 2 copies of the X chromosome, that's that big one, and males have 1 copy of the X that they get from their mom, because females have 2 of them, and so every time a female cell goes through meiosis, its only choice is to give an X. But males have an X and a Y. So if a male gets a Y, it's from their dad. So when sperm cells are created, 50% of them will have X's in them and 50% of them will have Y's. If you think about it, half of the human population has 2 X's. So obviously there's no vital to life information carried on that Y chromosome. The X chromosome has a lot of things on it that are not necessarily, it doesn't necessarily have to do with sex, just because females have 2 of them. So the ability to see red and green colors are on the X chromosome. The ability for your blood to clot is on the X chromosome. So that's why there are some diseases that males have more of, because they have only 1 copy of that X. So if that copy has a mutation in it, males are more likely to have hemophilia or to be red-green colorblind. The Y chromosome itself really just has some genes that like turn on like different receptors, like turn on your androgen here, or, but they're not essential to life. But not every animal determines sex the same way. So they're not all using these X and Y chromosomes. So birds, for instance, the males both have the same chromosome. So instead of X's, we call them Z. They have 2 of them. And the females are the ones that determine the sex of the offspring. Females have W and E. In some insects, this is not all insects, but just the ones that tend to have a queen, like ants and bees and wasps, for them, the sex is determined by whether or not the egg is fertilized. So females are 2N. They come from a fertilized egg. Males are just N. It's an egg that's never fertilized. It's gone through meiosis, so it has half the number of chromosomes, but it never got fertilized. So those are the males. And that has really interesting implications for their behaviors. As you know, these ants and bees and wasps have these very interesting like hives or nests with 1 queen and a lot of workers. And we'll talk about that when we talk about animal behavior. And then some reptiles, but not all, but turtles, their sex is determined by the temperature at which the eggs incubate. So I'm just thinking of a good question for discussion now. So I'm writing that down. So so females are produced from warmer eggs, and males are produced from colder. And it doesn't necessarily mean that on one beach it's all females or all males. It could be even within the same nest. If it's dug in a hole, lower down is a little cooler. Higher up in that hole on the beach, it gets a little bit warmer, and those may be the females on top and the males on the bottom. So it's just a different way of determining sex. But what happens when there is a problem in the chromosome numbers, right? So meiosis is complicated, right? There are two different divisions that need to take place. It goes through meiosis 1 and it goes through meiosis 2. And if anything goes wrong in any of those spots, the resulting egg or sperm could have too many chromosomes or not enough chromosomes, right? If that happens in a skin cell, you've got one funky skin cell. But if it happens, cells will have that problem. So, I just want to talk a little bit about the impacts of that. And a lot of the research and the information that's out there has been done on the impacts of, the eggs. So it looks like a lot of this is kind of blaming the mother. There's more and more and more research showing that, advanced paternal age can impact offspring as well. So I don't want you to think here that all of this only relates to females, but meiosis is definitely affected by age, especially in women. So when females are born, they are born with all of the eggs they will ever have in their life. So those eggs are developed in utero before you're even born. There's like 100,000 eggs or something like that. And some of them may begin to go through meiosis and then kind of pause and not finish meiosis until later. So as they age, some of that chromosome separation during anaphase, that's happening in an old egg, right? It may have been there for 30 years or 40 years. And so when the chromosomes are supposed to, one go this way and one go that way, they might both end up going in one direction or both go in the other. Or in meiosis 2, when they're lined up like this, right, these two might stick together and both go in one direction instead of splitting up. So this can happen in either meiosis 1 or 2, and it results in extra chromosomes. Sometimes a fetus that has too many chromosomes just will not survive. So that would result in a miscarriage. But there are some chromosomes that you can live with an extra one of. And the chromosome 21 is one of those. So trisomy 21 results in Down syndrome. Many of you may have met individuals with Down syndrome. They can definitely survive with Down syndrome, but there are some health implications to it. And you can see that as women age, especially as they get right to here to 40, the risks of that increase. So over 40 is considered a geriatric pregnancy. So this is not to suggest that everyone should run out and have a baby right away, but just to be aware for women of the risks of complications as they age. And again, I want to stress that there is more and more evidence that there are some male that men could pass on more diseases or their children could have other issues as men age. But certainly men can have issues into their can have children into their 70s and 80s, whereas women can't. The eggs just age out. So you might think, well, freeze the eggs, right? That's the perfect solution to all of this. And certainly like in the 90s and early 2000s, maybe like the 2000s, I'd say, women started really doing that more and more, thinking like, I want to have my career now. I want to get through school, do all these other things, and then I'll have children later. And there are companies like Google and Apple that were paying for women to freeze their eggs. So they didn't need to worry about it. Like just work a lot, and then you can worry about the kids later. But there was very little data on how effective that process was. So as you probably know, couples can freeze a fetus very successfully, right? You can have a frozen embryo that you then can defrost. And zoos even do this with animals. They could have a frozen embryo, they can have frozen sperm that they then implant in another animal. But they have been unsuccessful in freezing eggs. So if you have a female that's like unrelated to a lot of others and you want to be able to wait until like the right male comes along for your breeding program of your endangered species, freezing those eggs has not been a successful thing. And it turns out it's been the same for humans. So this is, you know, from the 2017, so it's a few years old, but you can see the success in actually having a live birth from frozen eggs. And certainly it depends on how old the woman is when she freezes her eggs. If she's less than 35, she's got a much better shot, but she's going to have to freeze a lot of eggs. And as she gets older, as the egg quality decreases, the chances of that working decrease. Obviously, reproductive technology is growing in leaps and bounds. Something could happen, you know, tomorrow that changes this. But everybody should go into these decisions and calculations looking at data. So don't just believe what everyone says, like, oh, do this, it works. No, say, okay, show me the data. How successful has this procedure been? So just plan and be aware of issues, you know, if you think you want to have children at some point. Okay, so how do we know then when these, like when there's an embryo, if it, you know, are there too many of one chromosome or something like that? And we do that by looking at a karyotype. So this is just like an actual, like you get, you take a cell and take all the chromosomes out and line them up and pair them up and see who lines up with whom. So obviously specialists have to do this. I have to say, if you ask me to tell the difference between like number 21 and number 22, I wouldn't be able to. But here you can see they've lined up all of the chromosomes 2 by 2. In your head, think about whether this is a male or female for a moment. And it is a female because there are 2 X chromosomes. And then we can look at this other karyotype down here at the bottom, and you can see there are 3 chromosome 21s. So either they got 2 from their mom or they got 2 from their dad, right? It doesn't mean this was the mom, but they definitely have 3 of them total. So one of their parents gave them 2. And you can see that this individual has an X and a Y. So this is a male. So how does this happen? Again, it can happen in meiosis 1 here. You can see in meiosis 1 is where the problem showed up. And then, so this, you know, the resulting eggs or sperm, 2 of them have 1 less chromosome and -1, and 2 of them get an extra chromosome. Or it could happen in meiosis 2. So both of these, either way, is possible. And this is just, again, explains why age tends to affect eggs more than sperm, because sperm are regularly created. However, again, paternal age is associated with some diseases. And I think one of the issues is this is only recently being studied. The medical community, you know, for the past 40 or 50 years was like, well, of course it's the mom's fault if something happened. And they're only starting to look at, well, I wonder if maybe it's the dad, like the dad's age also has any impact on it. So it's an area that hasn't been studied a lot, but as it is studied more, they realize that yes, the father's age and health and all of that also impact the offspring, not just the mom. And then it's always interesting to think about, well, what if instead of getting 3 chromosome 21s, what if it's the X or Y that is like misnumbered in there? So this is, you guys don't need to memorize this, but it's just interesting to look at. So if the individual has only 1 X and that's it, no Y, no second X, and that could happen from having a sperm with no X or Y in it, or nothing in the egg and just a sperm with an X. That ends up being someone with Turner syndrome, and they would be short. They might be sterile and have some learning disabilities. Someone who is XXY, either because they got 2 X's from the egg or 1 X from the egg and an X and a Y from the sperm. So the chromosomes didn't divide during meiosis in the sperm. That individual would look male, but have underdeveloped testes and have low testosterone levels, they'd also be infertile, and they'd be tall, whereas the Turner syndrome person up here would be short. You could have XYY, and obviously that is from the sperm carrying two Ys. So something happened to meiosis there. This individual would be tall, have acne, and low intelligence. And you could also have the triple X, which can only happen if the egg doesn't properly go through meiosis, and then you get an X sperm. This individual might be sterile, but otherwise physically you couldn't tell by looking at them. So that's just, what could happen and the impacts of that. All right, so that is it for chapters 6 and 7. Go on into your discussion, and I'll see you there.